Now we move on to chemical formulas, which is the way compounds are written. For example, water, dihydrogen monoxide, is written as H2O. This means that there are two atoms of hydrogen combining with one atom of oxygen to form water. The little subscript right here tells you the number of atoms that are in said compound, and if there's no subscript, then it is implied that it is 1. We have sodium chloride, 1 atom of sodium and 1 atom of chlorine, and acetic acid or vinegar, 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of oxygen. We have an empirical formula that shows the smallest number of atoms in a compound. For example, acetic acid. The empirical formula is going to be CH2O. Molecular formula shows the actual number of atoms in a molecule. Acetic acid again, there's actually 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of oxygen. And finally, the structural formula gives information about the arrangement of atoms. Acetic acid can also be written like this, CH3COOH. This means you got your carbon here with 3 hydrogens on it. You got a carbon here, and then it's attached to 2 O's, and then the O is attached to an H. We next have chemical equations. These are how chemical reactions are written. And a chemical reaction, you have reactants, which are what are used to form products. Water is formed by hydrogen gas and oxygen gas. Water is formed by hydrogen gas, oxygen gas. That's what I just said. Sorry. Anyways, these chemical equations have to be balanced, just like a math equation. You have to have the same number of things on the left side as the right side. So, in order to balance this equation, we start off, you have 2 atoms of hydrogen, 2 atoms of oxygen. But on the right side, you have 2 atoms of hydrogen, but only 1 atom of oxygen. So, in order to balance the equation, you have to add what are called coefficients, which are just numbers before the reactant. So, to balance this equation, you want 2 molecules of hydrogen gas, 1 molecule of oxygen gas, and then you have 2 molecules of water. This is a multiplier, so you have 2 oxygens, 4 hydrogens, which equal 2 oxygens and 4 hydrogens. Now we move on to chemical bonding. There are a couple of different types of chemical bonds that can be formed. The first type is an ionic bond. Ions are atoms with a charge, like chloride ion, sodium ion. This means that an atom has either gained or lost electrons. Remember, if you gain or lose protons, you change the element. So for example, you have your sodium atom here, your chlorine atom here. This is just going to take an electron to form a bond. Because like I said, you either want to have a completely full valence shell or a completely empty valence shell. So this chlorine atom right here is going to take this electron from sodium. Sodium's valence shell is empty, chlorine's valence shell is full. These types of bonds don't form molecules, and it's basically just an attraction. So you can have a sodium atom here with a bunch of different chlorine atoms attracted to it, because both of these atoms have a charge on them. Sodium is going to have a +1 charge, chlorine is going to have a -1 charge. These bonds are pretty weak. They form, and whenever you dissolve salt in water, it's going to form ions. Covalent bonds form when atoms share electrons. This means electrons are going to spend some time on all the atoms. For example, you have nitrogen gas, which is written N2. you have your electron density cloud right here, which is where the electrons can be found orbiting around the nucleus. These electrons are going to be attracted to the other nucleus. For example, these electrons are going to be attracted to this atom's nucleus. So eventually, these electrons are going to be shared, a covalent bond forms. The same thing happens here with methane, CH4. Electrons are all shared. There's one electron from hydrogen, shares with one electron from carbon. Carbon has 4 electrons that can be shared, so it's going to share all 4 electrons with 4 different hydrogens. Shared electrons are called an electron pair. You have a single bond when 1 pair of electrons are shared, a double bond when 2 pairs of electrons are shared, and a triple bond when 3 pairs of electrons are shared. Single bonds share 2 electrons, double bonds share 4 electrons, triple bonds share 6 electrons. And when electrons spend more time on one particular atom, you get what is called a polar bond, polar covalent bond. This means that each atom is going to have a partial charge. Oxygen is going to pull electron density from hydrogen, so oxygen is going to have a partial negative charge. Hydrogen is going to have a partial positive charge. And the last thing I'm going to talk about in this video, because it's already 13 minutes long, is hydrogen bonds. These result from the weak electrical attraction between a partially positive hydrogen atom and a partially negative atom. The ones you need to remember are oxygen, nitrogen, and sulfur. Those are the big ones in organic systems, living systems. But basically what's going to happen is you're going to have this partial positive on your hydrogen atoms, a partial negative on your oxygen atoms, and these are just going to form really weak attractions. The partial positive hydrogen atom is going to be attracted to the partial negative oxygen atom. And these just form a bunch of different little bonds in water. But I'm sorry this video was so long, but there's a lot of stuff to cover. I know this is very brief or not very detailed, but these are just the basics of what you need to know for biology.